Hello everyone, this is Brock Skaggs, and I'm going to make this video where we're going to do some part modeling inside of SolidWorks, and we're going to try to model this heatsink part that you see on the screen now. And so we got a nice 2D kind of orthographic projection style drawing of this heatsink. Kind of think of the heatsink that you may find on the back of a computer, like inside the computer where you have the CPU. This may be something like that sits on top of the CPU that's trying to wick that heat away from it and keep the CPU cool as it operates. Maybe as you're playing some intensive video game on the screen or doing some sort of other intense computation. So, usual things we look for at the very beginning here. Check the units. It looks like in the title block we're saying the dimensions are in inches in a couple places. Material 6063-0, so an aluminum alloy there. Let's also try to make it look in the isometric view, like we see here in the top right. And we've got an origin placed right there. You can see from the front view it looks like it's in the middle, going left to right and on the very bottom plane there. A couple other items as we look at this heatsink design. One thing is we've got a lot of these pin fins, if you will. Looks like there's 6 by I think 12, so that'd be what, 72 different pins there. Obviously in SolidWorks we don't want to go through and model each one of those individually, so we're going to be taking advantage of a linear pattern. We're going to be patterning in 2 directions simultaneously in order to create that grid structure there. Another thing to note about those pin fins is they're not just a straight boss extruder, right? That cross section is actually narrowing a little bit as we move to the top there. So there is a boss extrude with a draft angle, but instead I'm going to take this opportunity to look at the Loft Tool inside of SolidWorks there, and we may play around a little bit when we're at the Loft Tool to maybe see something like a guide curve there as well to kind of change the shape as well, just to kind of explore the flexibility of that tool. Alright, so as that is the introduction, let's go ahead and get going. Switch over here, and I've got SolidWorks up. I need to create a new file, so I just want File New, and I'll just type or select that part IPS ANSI template and let it load up this initial template for us. And there we go. So as usual, we got the front, top, right planes and origin there. We did say it was an aluminum alloy 6063-0, so I'm just going to go ahead and start right there. I'll right click. I don't see that in kind of the common quick access items here, so I'll have to go to Edit Material. It is an aluminum alloy, so I'll collapse the steel node and go to aluminum alloys. And we're just going through this sorted list. And right there is 6063-0. I'll apply and hit OK. So at 63-0, we are in the English unit system, IPS, so that passes those 2 checks. Now let's go back to that drawing. And so if we want this to look like the model in the isometric view, I'm going to start off with this kind of base plate that these pins are on. It's 3.125 or 3 1/8 of an inch in the width and height, if you will, from the top view there, and it's 1/8 of an inch thick there. So if I want it to look like this in the isometric view, I need to model that first sketch. If I model it as if it's this rectangle here, the 3 1/8 by 3 1/8 rectangle, on the top plane, and then I'll be extruding upward in order to create that origin on the very bottom. So that'll be our initial plan. So I'm just going to click that top plane right here from the tree structure and create a nice 2-dimensional sketch using the right mouse gesture there to get into the rectangle tool. And so I've got my rectangle drawn. Now let's get this origin right in the middle of this line here. So I'm just holding Control, getting the 2 selected, and right there is our nice midpoint geometric relation. Alright, so we're looking pretty good. We did say that these are both equal, so let's go ahead and tell the model that. I'm holding Control, selecting both those lines, and now I'm going to say, hey, these line segments are equal. Get the sketch modeled or zoomed in correct here, and we said that was 3.125 inches, so I'll just smart dimension 3.125 here. Very good, nice closed sketch, fully defined. So now I can go straight into the extrude boss and base, and I think it was 1/8 of an inch is what we had there, 0.125, and create that solid geometry. Yep, it was 0.125. All right, so just kind of a sanity check here. I put in the isometric view with Control 7. There's the origin right here. That looks good, and that looks like we're headed in the right direction to create that geometry when we're in the isometric view. Alright, so with that being done, let's go ahead and hop into these pin fins here. And so one thing I'm going to do here is I'm going to use a feature pattern after I get done with the loft feature. And so I need to create some sort of seed feature. And so for a seed feature, kind of the original one that I'm going to use then to make copies of, I'm going to focus in on this one here in the very bottom left, where I've got a lot of these dimensions tied to this guy right here in my detail view. And so basically the idea is going to be to model this guy up, get a solid body type feature made that we're happy with, and then we'll duplicate it or clone it, if you will, multiple times to create the array of fins. So we're going to use a Loft Tool to do that, so that's a little bit different. And so with the Loft Tool, one of the things we're going to do is we're actually going to make two different sketches that are going to be consumed in the one loft feature. We'll make a sketch here on this bottom plane, and then we'll make a sketch here on the top plane as well. And so that'll allow us to then describe the cross section at both of those 2 points, and then we're going to basically use the Loft Tool to map the geometry in between those. And then this idea of mapping the geometry in between can become as complex as needed, so to speak there. And the finalized one you see on the drawing here, it's very straight. It's just kind of this linear mapping between the different control points on both the sketches, but you can do something more exotic as well. And so let's just go ahead and hop into this. I'm going to go ahead and select that top plane and create a sketch. Again, we just kind of have a rectangle going here, so just go center point rectangle here. And what do we have here? It looks like this bottom left corner of that rectangle is 1/8 of an inch by 1/8 of an inch from the sides. So let's go ahead and put that piece of information in. This geometry here is 3/8 by 1/8 as far as the actual dimensions of the rectangle. So we'll add that in at this point as well. So that's looking very good. Probably doesn't matter. I'm going to go ahead and leave off the rounds here, and I'll put those in as a feature when we're done creating the solid geometry. So I'm just going to accept that. And now you can see I've got this nice sketch sitting on top of this plane. And so I now need to create a sketch that's on a plane that's parallel to that top surface, but it's 1 inch above. And so I don't have a plane there, so I'm going to have to create a reference geometry plane. So this will help me have a plane, if you will, to create my next sketch. So there's lots of ways to define your planes, and so this is a very simple way. I'm just going to say, hey, I want to reference this flat planar face, and I want to create a plane that is parallel to it, but it's going to be offset by a certain distance. And that certain distance, you can see from the drawing, is 1 inch. So we just come up here to the dimension slot, and now I've created that nice plane one there. So if I come back, I can now see it kind of hovering above that top surface. So that's all looking good. And if I read the note here, basically that top sketch, that cross section there that we're going to define, is basically another rectangle, but it's 25 thousandths inset for that top rectangle. So what I'll do here is, like we're used to doing, I'll click that sketch or that plane and create a new 2D sketch. And I can now see that existing rectangle from the previous sketch, and I'm going to go to offset entities, and notice I can just click on it. I'll need to reverse the direction. It went away because that offset's too big. And if I just enter that desired offset of 25 thousandths, notice I'm able to create that nice geometry. You can see I've got the preview here, and I'll just accept that. Alright, so that's looking really good. If I rotate it out, you can see now I've got that second sketch with a rectangle there hovering above the first. Alright, so now I've got these two sketches. They're separated by 1 inch. They're on planes that are parallel. And now is where the magic is going to happen associated with this lofted base. And so I'm going to use this guy right here from the command manager, the ribbon interface. I've got the lofted base. And so I guess don't be too intimidated at this point. We've got multiple things happening here on the left-hand side pane, but the profile, these are those two-dimensional cross-sections that I was describing. And so we've got this direction we're kind of pulling these things through. In this case, it's the y direction, so it's like you're defining the cross-section at different points along that y-axis. So in this case, I'm going to just click right here. And notice it grabbed that top right corner, and so I'm going to be somewhat particular when I pick this top one and make sure I click fairly close to that as well. And so now I'm seeing the geometry. It's basically saying, hey, you've told me 2 sketches, and so I'm going to map what would be the geometry in between there. And so some things to be careful of is you've got these little green icons that are showing up here. Those are kind of the control points or the connector points. You can actually show all the connectors here, and you can see that there's multiple of them there. And just because of the way I selected this, but being close to the top right here and close to what I'll call the top right there, it made this nice linear mapping where you can see all of the vertices are going to the corresponding vertice each time. And just to go ahead and accept this, you can see this creates this nice kind of tapered look of the pin fin itself there. But if I go back in here just to show what can happen at times, if I start to drag this a little bit, and notice I just pulled it to the other side, if I hit show all connectors here, you can see now I've kind of rotated that one over, right? And you can see it kind of gets this twisted approach. And so this is where the Lofted Geometry can create somewhat exotic looking shapes, because now I've got this thing that's kind of rotated a bit. And you can get into trouble with this as far as if I move it too far. Notice here, it's not going to let me even build the geometry. And the reason here is because I've got some self-intersections happening, where the geometry is twisting to the point where it's kind of doubling back on itself, and SolidWorks isn't liking that. And so that's one thing you can do with the different geometries here. I'm just going to back all the way out. Sometimes when you get to fiddling with it, it's easier just to here come all the way out, delete it in, and put it back in place. And so we do have this option. And this is the option that we're actually going to go for in the end. But since I'm here and we're talking about it, it may be worthwhile to actually model something as well, just to show you what like these guide curves can do. And so let's take a little brief aside, if you will, or tangent to talk about these guide curves. And so what if you wanted that to be a different mapping and not just like rotating among the vertices, but you actually wanted these fins to curve a little bit? And so we can make that happen. I'm going to do that first here. I'm going to come in and edit this sketch because I want a piece of reference geometry is what I'm looking for. And so what I'll do is I'll just go ahead and create a reference line here. It's all the way across. Really what I'm interested in is finding the midpoint of that. And so what I'm working toward here is I want a plane that's running perpendicular, kind of parallel to what would be the YZ plane in this coordinate system, and going through the middle of these rectangles. And so by putting that point in there, that'll give me something to work with. So like now I've said, hey, I've got those 2 points, and now it's kind of going to be able to rotate about those 2 points. And then I'll reference that plane. Instead of being perpendicular, I want it to actually be parallel to it. Oh, I got some invalid combinations there, so I'll go ahead and remove that first one. And now, yes, that's looking nice. Sometimes you just have to play around with those references until you get something that's agreeable with you. Alright, so now I've got that plane 2 that's right in the middle, and we're going to create a guide curve, and this gives you more control over how SolidWorks is mapping between those 2 cross sections we define, or what they call profiles. And so I just created a sketch here on that plane, and what I'm going to do is I'm going to actually start describing the geometry in between it. And so what I'm attempting to do here is define this curve, and one thing I want to make sure is that I've either got a Pierce relationship or a coincident relationship to these 2D profile sketches that helps connect the geometry all the way through. I like looking at on the left here, and let's define something here. Let's say it's 2. Whoops. And you can see I haven't quite attached it down here, so let's go ahead and make sure that's, let's say, Pierce as well. Always wanting to fully define those sketches. So that's looking good. Trying to think if I want to pull the other one. Yeah, let's go ahead and pull the other one as well. So let's just replicate that on the other side. So we can kind of pull both of these. So again, just making sure that that guide curve sketch is attached. That's what those pierce relationships are doing. And just for the sake of illustration, show that we can do this with two different radii. They don't have to be the same. Alright, so now I got this kind of weird connection curve between the two profiles, if you will. And now when I go to Lofted Base, I'm going to do the same thing originally here. I'm going to click on those same rough locations, and I got this linear one, but you say, hey, I really don't want those to be straight. I want them to kind of bend along these arcs. And that's where these guide curves come to play. So I can click that one. It's saying, hey, I want to select an open loop. Yes, that's correct. It's doing this because I have those two open loops inside of the same sketch. And now if I accept that, notice now how I've controlled how the loft is transitioning between those two profiles. And you can imagine this could get very complex there. I could have some very complex curve that's connecting these two things, and the guide curve would follow that shape. So just looking at some of the more advanced things you can do with lofts while we're creating these pin fins. But if I'm trying to replicate that drawing, I don't really need that. And so we got all that deleted. Yes, and we're back to this. So I'm going to quickly go ahead and just recreate, I don't know, for the third or fourth time, that loft feature for us. Alright, so I've got the loft. If you notice in the drawing, somewhere here, yep, rounds and fillets are 25 thousandths all as well. So let's go ahead and do that with a feature fillet. 0.025 is the radius. I'll just come in here. And place those in. Looking good. And now we just need to replicate this over and over. And so I'm going to go hide that plane. And so to replicate this, you'll want to use a linear pattern. There are other types of patterns, as you can see here. Some of them get fairly exotic, like these table-driven patterns, variable patterns, fill patterns. But we're just doing the first one on the list, linear pattern. So it's got direction 1, direction 2. I usually like to jump down here to the features pretty quick. You just be able to say, hey, I'm patterning this loft and that fillet. I can put multiple things in here. The directions, you can use reference geometry to define directions, but you can also use solid geometry as well. So in this case, my direction one will say is just that axis. And you can see I'm starting to define what this is going to look like. It looks like the spacing is 1/2 inch. And I believe there's 6 items there, so you can see it's going to make an additional 5 copies to get 6 in the row. Now it's on distance 2, or direction 2, so I'll define that one. Well, we're going the wrong way, so we'll flip it with that button there. And then look on the drawing, it looks like a 1/4 inch offsets here. Looking good. Got some real estate back here, so I think it is 12, so 11 and 12. Yep, fits nicely. And I'll go ahead and accept that as well. So it's taking my laptop just a moment. But now we've arrived at the pin fin heatsink array there. So everything's looking really good at this point, and we've got all those pin fins in place. But just to show one other thing that we can show fairly easily about this linear pattern is this idea of skipping instances before we jump out of this video. And so way down here underneath, there's this idea of instances to skip. And let's say, hey, they're not all here, but there's some of them left out. Oops. Didn't like it when I did that, so I'll rotate here. And so as you see, every one of these pin fins it's going to create has got this little purple node in it. And one thing you can do with this instances to skip is you can say you can box lasso, you can add alts. Oh, they've got some keyboard shortcuts is what they're showing here. But you can basically select different instances, and you can see as I select, they get loaded into here, into kind of a ordered pair type nomenclature for it. And I can come in here and actually remove some of these as well. And so I'm just picking some of them out of the array, and you can see when it created it, it actually left those instances out. So that's another place where you have a little bit more control over the array. Say you want to create most of them, but then just not programmatically, but manually select out the ones that you don't really need. And so just another small feature within the bigger linear pattern feature to help you create geometry. So hopefully everything made sense in this video, kind of what we were showing with the loft feature. We got a little bit deeper than just the surface loft, showing the guide curves in there if you want to control the geometry between those defined profiles. And then instead of modeling a whole lot of little fins, we just modeled one, and then we used that as a seed feature to drive the pattern itself there. So that allowed us to create, I think we had up to like 72 different fins there. And then we went back in just to show that skip instances feature and just manually removed some of them there. Alright, so I think we'll call it good for this video. As always, thank you for watching, and hopefully this helps you in your solid modeling.